Hi, welcome to my channel. In the previous video, we discussed about the definition of a decision tree, and some terminals of the decision tree, and also we discussed about the types of decision trees, the types of decision tree algorithms, like decision tree algorithms, like ID3 algorithm, C4.5 algorithm, and CART algorithm, CART, classification and regression tree algorithm. Okay, based on these algorithms, we can construct the decision tree and predict the corresponding value. Okay, in this video, I am going to explain about the training and visualizing a decision tree. Okay, now in order to understand the decision trees, first of all, you have to understand what is the decision tree. What are different terminals in the decision tree. Okay, here it contains, first of all, it contains some root node and intermediate nodes, node, like put in the form of a rectangles. Okay, and the leaf nodes. It can put in the form of a vowels. Okay, now the leaf nodes are called as a class labels, corresponding to class labels, and here intermediate nodes and root node contain the attributes. Okay, now we are going to check the condition on these attributes. Okay, in the root node or intermediate node. So based on this root node or intermediate node, we are going to check the some attribute condition. Based on the attribute condition, we can reach the leaf node. The leaf node contains the corresponding class label. So like that, we are going to construct the decision tree. So in order to construct the decision tree, first of all, you have to build one model. That means you have to use the ID3 algorithm, or C4.5 algorithm, or CART algorithm. Based on any one algorithm, you can use the any one algorithm. Based on this algorithm, you have to construct the decision tree, and then based on this algorithm, you are going to predict the corresponding class labels. Okay, so like that, you have to understand the decision tree. So we will train a decision tree classifier using the scikit-learn. From this scikit-learn, we are going to use, train the model with the help of a decision tree classifier. Now we are going to use some data set. The data set is called as a iris data set. That means we are going to train the decision tree classifier using the scikit-learn on the iris data set. So here iris data set is a one standardized data set. On this standardized data set, we are going to apply decision tree classifier. Okay. Now in the iris dataset, it contains, first of all, we are using the iris dataset. It contains sepal length, sepal width, petal length, and petal width. These are the features. Okay, these are the features, and the corresponding class labels are setosa, versicolor, and virginica. These are the three class labels are there. These are called as a corresponding class label. Okay, so here the sepal length is this is called as a sepal length, and this is called as a sepal width, and this is called as a petal length, and this is called as a petal width. Now based on these features, we are going to classify the given data. The given flower is a setosa, versicolor, or virginica. Okay. Now the iris dataset contains four features like petal length, petal width, sepal length, and sepal width. And the corresponding class labels are iris setosa, iris versicolor, and iris virginica. These three class labels are there, and four features are there, and totally 150 instances are there. 150 instances are there. That means each setosa class contains 50 instances are there, and versicolor contains 50 instances are there, and the virginica also contains the 50 instances. So that is equally distributed all the three class labels. Okay. Now this is about the some information about the iris data set. Okay, so here we are the some of the features of the some of the values of the sepal length, sepal width, petal length, and petal width, and the corresponding class labels are setosa, versicolor, and virginica. So totally 150 rows and 5 columns are there. Okay, this is about the overall view of the our data set. Okay. Now, in order to training and visualizing decision tree, first of all, you have to follow some procedure. Okay, you have to follow some steps. Okay, so here the first step is load the iris dataset using the scikit-learn and select only petal length and petal width features. So here we are having the four features are there: sepal length, sepal width, and petal length, and petal width. These are the four features are there. Okay, the index of that one is 0, 1, 2, 3. Okay, and this is the corresponding class labels. Okay, these are the corresponding target variable. Okay, species is a corresponding target variable. Now these are called as a features. Okay, we are selecting only sepal length and petal length and petal width features for the from the our data set. Now train our decision tree classifier on the iris data set. So that means we have by using the scikit-learn, we are going to use the decision tree model, decision tree classifier model on this on the iris data set. Then visualize our decision tree using the export Graphviz method. Okay, so you can visualize our decision tree based on our model. Then export Graphviz gives us a file in the form of a dot format, which will be converted into PNG using the dot command line tool. Okay, based on these steps we have to visualize our model. So now here we are going to see some code for how to we are going to train the model. Okay, first of all, from the scikit-learn dot datasets, from the scikit-learn dot datasets import load iris dataset iris. That means here iris is a standard dataset that is automatically available in the scikit-learn dataset. So we are directly importing from the corresponding datasets. Okay, load iris dataset. Then our model is a decision tree classifier. So we are going to import the decision tree classifier from the scikit-learn tree. Okay. Now we are going to load the iris dataset. Okay, that is in the iris. Iris equal to load iris. Now whatever the data is there, that is stored in the iris variable. Then we are dividing the data into two parts. One is x and one is one is y. This is called as x and this is called as y. And x is nothing but in the x we are going to read the only petal length and petal width. So the index of this one is 0, 1 and 2, 3. So in our case, x is equal to iris dot data of all rows. Okay, I accept all rows and from the 2 to 3. That means petal length and petal width are going to be assigned to our model. Okay, assigned to our model. So x contains only petal length and petal width. Now y equal to iris dot target. Iris equal to iris dot target. Whatever the target variable is there, that is assigned to corresponding class label y. Okay, now we are going to train the model. So the model is equal to our model, that is a tree classification equal to decision tree classifier, and the max depth equal to 2. So the depth of the tree is like here. The depth of the tree is like here. This is depth 0, depth 1 and depth 2. Like that, the max depth here equal to 2. So up to that 2 level, we are going to construct the decision tree. So for that, we are providing the max depth equal to 2. So our model is equal to a decision tree classifier. We are importing from the scikit-learn tree model. Okay. Then train the model. So tree classification fit is a method used to train the model with the help of corresponding features and corresponding class labels. So we are providing the model. For that we are going to train with x and y. Here x nothing but here petal length and petal width of the 150 rows, and y nothing but corresponding target variables, okay, of 150 instances. Okay, now based on these steps we are going to train the model. Then we can visualize the trained decision tree by using the export Graphviz method to the output graph. Okay, define file called as a iris underscore tree dot. Okay, here we are going to use the one method called as a from scikit-learn dot tree. We are importing the export underscore Graphviz. So here this method contains for this method we have to provide the export underscore Graphviz. We provide the type of our model, trained model, that is a tree underscore classification, and the output file contains the image path. The path of the corresponding file equal to iris underscore tree dot. Okay, and the feature names are feature underscore names equal to iris dot feature names. Feature names are nothing from the here 0 and 1, 2 and 3. So the corresponding class labels from the features names are petal length and petal width, and class names are equal to iris dot target names. So here this is called as your target names. What are the target names? Setosa, versicolor and virginica. and rounded equal to true, and filled with equal to true. So based on these steps, we are going to visualize our model. Then we can use the dot command line tool from the Graphviz package to convert this dot file to a variety of the formats like PDF or PNG file format, or image file format, or PDF file format. Okay, this command line converts the dot file into a .png image file. Okay, so now $.t png iris underscore 3 dot hyphen 0 hyphen o iris underscore 3 dot png. That means what are the output target file is there, that is converted into image file format. Okay, now we can, first of all, you can here we are going to generate the one image file format. Okay, so this contains the this is called as root node, and these are called as intermediate nodes, and these are called as a class label. These are called as a leaf node. This is one leaf node, and this is one leaf node, and this is one leaf node. Each leaf node contains corresponding class labels. Okay, so here our model is a decision tree classifier. The default one is a CART algorithm. So why are using CART algorithm? The default value is here using Gini value. So if the value is using the Gini value, then automatically that is the model is CART algorithm only. Okay, so here we are using the two features only. Okay, that is petal length and petal width and species. This we are using this is the data set. Okay, it contains only two features and corresponding class labels. Okay, okay, now based on the two features, that means this is one feature and the second feature and corresponding class labels. So based on first feature, first of all you have to identify which is the root node. There are two features are there. One is petal length and petal width. In order to identify the petal length root node, first of all we are going to use find out the corresponding Gini value. Okay, now based on Gini value is the highest for petal length only. That's why the petal length becomes the root node. Now here the petal length is equal to 2.5. If less than equal to 2.45, less than equal to 2.45, all are belongings to it contain belongings to Setosa class. Okay, now here we are going to check the condition like Gini value equal to 0.65. The samples are 150. There are 150 samples are there, and the values of the things are 50 Setosa, 50 versicolor, and 50 virginica. Now the class equal to Setosa. So here if the condition is true, then all the elements are belonging to Setosa only. So the condition true, then all the elements are belonging to Setosa only. That means Gini equal to 0. Gini equal to 0 means all the samples in the corresponding content becomes same class. Okay, there is no alternative elements. Okay, now samples equal to 50, value equal to 50, 0, 0. That means all elements are belonging to Setosa only. 0 element belonging to versicolor, 0 element belongs to virginica. Okay, so now the corresponding class type equal to Setosa only. So why here the Gini equal to 0? That means all elements will becomes same class only. If the all elements will belong to same class, then automatically the corresponding Gini value equal to 0. Okay, so if the condition is what the condition, the root node condition is petal length is less than or equal to 2.5. If the condition true, all are belonging to Setosa only. If it is false, then the remaining elements are becomes it may be a versicolor or virginica. So now here we are having the samples are 100 samples are there, and out of 100 samples the 0 elements are belonging to Setosa, 50 belonging to versicolor, and 50 belonging to virginica. Now we are going to check the condition. The condition is we are going to check the other alternative attribute, that is petal width. Okay, the previous attribute we are check the petal length. Now we are going to check on the petal width. So now this is the attribute. On this attribute we are going to check the condition. The condition is equal to, if the value is less than or equal to 1.75, then those belong to versicolor, otherwise those are belonging to virginica. Now here going to check the condition equal to Gini equal to 0.5. What is 0.5? It contains 50 elements are belonging to versicolor, 50 elements are belonging to virginica. Half of elements are belonging to versicolor, and half of elements are belonging to virginica. That's why we are getting the Gini equal to 0.5. Now if the condition is true, then we are going to divided into two parts. One is one is versicolor and one is versicolor. Okay, now here we are going to level 0, level 1 and level 2. So we are going to stop that location. So at our max depth tree equal to only. So that's why we're going to stop that this location. Then we at the bottom level we are going to have the class labels. So here the samples are 54. Out of 54 samples are value equal to 0 belonging to Setosa, 49 belonging to versicolor and 5 belonging to Virginica. Now the majority class belonging to versicolor. The majority belongs to versicolor and the corresponding Gini value equal to 0.68. That means here most of the elements are belonging to 49 and 5 are belonging to Virginica. So now if that means Gini not equal to 0. Okay, that's why they contain the different values. Okay, now we are going to write this condition. Now samples belonging to 46, value equal to 0, 1, 45. That means 0 belongs to Setosa, 1 element belonging to versicolor and 45 belonging to Virginica. Like that, the majority class belonging to Virginica only. Okay, so like that we are going to identify the class labels. So here the first class label is Setosa and the second class label is versicolor and the third class label is called as Virginica. So like that we are going to find out construct the decision tree with the help of cart algorithm. So in the cart algorithm we are going to use the Gini value. Okay, based on the Gini value we are going to construct the decision tree. So this is about the decision tree visualization. Okay, like this we are going to train the decision tree and the visualization of the decision tree. In the next video, I am going to explain about how you can make the prediction for the given data set with the help of a decision tree. Thank you for watching our video. If you like the video, please subscribe my channel.